Okay, so get ready for this one because today we are diving into something really unexpected. How ordinary grapes from the supermarket are sparking a revolution in quantum technology.
Grapes.
Yeah, you heard that right, grapes?
Wow.
We're talking tiny diamonds, glowing plasma, and the future of sensing technology, all thanks to the humble grape.
It's amazing.
It really is. And we have this fascinating article from Macquarie University titled Supermarket Grapes Spark a Quantum Technology Revolution, published just last week on December 31st, 2024.
Yeah.
So we're going to unpack this amazing research and see what you can take away from it. Get ready for some aha moments. I guarantee you'll never look at a grape the same way again.
I think that's a pretty safe bet.
Yeah, I think so too. So for anyone who's not seen those viral videos of grapes making plasma in a microwave,
Oh, yeah.
where have you been? Seriously.
Right.
But what's fascinating here is that this research goes beyond that electric field stuff that everyone was focused on. They discovered that pairs of grapes can enhance magnetic fields. And that's where things get really interesting for quantum sensing. But before we get too deep into the grapes, can you remind us what quantum sensing is and why we should even care?
Absolutely. So quantum sensing uses the principles of quantum mechanics to measure things incredibly precisely. We're talking about detecting magnetic fields at the atomic level.
Wow.
This has huge implications for fields like medicine, navigation, materials, science, you name it.
Okay, so we're talking about some seriously sensitive technology here.
Yes.
But where do the grapes fit into all of this?
Well, the researchers discovered that grapes, specifically the water inside them and their size, around 27 millimeters long, act like tiny resonators. They concentrate microwave energy into very specific spots.
Wait, so the grapes are basically acting like little antennas?
You could say that.
Yeah.
And here's the kicker. They found that water is even better than sapphire, a material traditionally used in quantum devices at concentrating this microwave energy.
Hold on, water is better than sapphire. This is huge. You're telling me we might be able to create quantum sensors that are cheaper, more efficient, and readily available by using, wait for it, water.
It's pretty amazing.
This could revolutionize the field. But doesn't water lose energy really quickly? Isn't that kind of a problem?
You're absolutely right. While water is great at focusing the energy, it also loses it quickly, like trying to fill a leaky bucket.
Oh.
That's one of the biggest challenges the researchers are working on. They're now trying to find other materials that can mimic water's abilities but are way more stable. Think of it as finding the quantum grape 2.0.
Okay, I get it. Finding a stable quantum grape is the next big step. But how did they even measure these enhanced magnetic fields in the first place?
Right. To measure those enhanced fields, they use something called nanodiamonds with nitrogen vacancy centers, or NV centers for short. Imagine these nanodiamonds as super tiny compasses,
Okay.
except they're way more sensitive than any compass you've ever seen. These compasses, called NV centers, are what pick up on even the smallest changes in the magnetic field around the grapes.
So we've got these grape antennas concentrating energy, and then these nanodiamond compasses detecting the changes.
Got it.
But how do they actually set this whole experiment up? It sounds pretty high-tech.
It's actually quite ingenious in its simplicity. They placed a diamond with NV centers between two grapes. When they shone a green laser at the diamond, the NV centers glowed red.
A green laser makes a diamond glow red.
Yeah.
That's wild. So what does the red glow tell us?
The brightness of that red glow tells us the strength of the magnetic field around the grapes. The brighter the glow, the stronger the field.
So it's like a visual representation of the quantum mechanics at work. That's one way to make this complex science a little more relatable. Okay, you got me hooked. But let's step back for a second. What does this discovery actually mean for the future of quantum technology?
That's where things get truly exciting. This discovery has the potential to lead to smaller, more affordable, and more efficient quantum sensing devices. Remember all those applications we talked about? Medical imaging, navigation systems, materials, science?
Yeah.
This research brings us a step closer to making those possibilities a reality.
Well, hold on. You're telling me this grape tech could impact everything from finding a tumor to mapping a black hole. You've got to be kidding me.
Yeah.
But let's be real. What are the limitations here? It can't be all sunshine and rainbows, right?
Well, remember that instability issue with water we talked about?
Right.
That's a major hurdle. Researchers are working on overcoming that by looking for new materials that can mimic water's unique properties while being more stable and efficient.
So it's a race to find that perfect quantum grape 2.0, right? I'm guessing there are other challenges too.
Absolutely. But even with the challenges, this research is a huge step forward. It shows us that even the most ordinary things can hold the key to extraordinary scientific breakthroughs.
I love that. And speaking of breakthroughs, let's dive into some of the specific ways this technology could change the world.
Let's do it.
We'll be right back after we take a moment to catch our breath to explore those potential applications.
Sounds great. So before we took a moment to catch our breath, we were talking about the potential of this grape-powered quantum technology. It's mind-blowing to think something as simple as a grape could change fields like medicine navigation and even our understanding of the universe.
Right, before the break we were talking about the challenges, but now I want to hear about the possibilities. You mentioned medical imaging earlier. How could this tech change how we diagnose and treat diseases?
Imagine being able to spot tiny tumors or abnormalities much earlier than we can now when treatment is usually more effective. That's the kind of precision we're talking about with quantum sensing.
So instead of waiting for something to become a big problem, we could catch things at the cellular level.
Yeah.
That's incredible.
Exactly. And we could even track how well treatments are working in real time, leading to personalized care and better outcomes. It would completely change the healthcare game.
Okay, color me impressed. But what about navigation? You said quantum sensors could lead to super accurate systems? Does that mean we ditch GPS altogether?
Not necessarily replace GPS, but definitely improve it and solve some of its problems. You know how GPS can be unreliable in cities or remote areas because the signals get blocked?
Oh yeah, totally. I'm always losing my GPS signal downtown. So frustrating.
Exactly. Quantum sensors, on the other hand, don't need external signals. They measure changes in magnetic fields incredibly precisely, meaning they could work anywhere regardless of satellite coverage.
So we're talking self-contained navigation systems that could work in a tunnel, a dense forest, anywhere. That's huge for autonomous vehicles, search and rescue. The list goes on. This is really starting to feel like sci-fi.
It is pretty remarkable, and it doesn't stop there. We haven't even touched on the possibilities for fundamental scientific research.
Oh, right. This isn't just about practical stuff. It's about understanding the universe on a deeper level.
Precisely. With quantum sensors, we could study magnetic fields at a level of detail we've never been able to before. Think about it. Magnetic fields are everywhere from the Earth's core to distant galaxies.
They're like the invisible forces shaping the cosmos. And with quantum sensors, we could finally see them with incredible clarity.
Exactly. Imagine being able to map the magnetic fields of distant stars or even black holes. It would revolutionize astrophysics as we know it.
This is all so exciting, but I have to ask, are there any downsides to this technology? It all sounds a little too good to be true.
Of course, as with any powerful technology, there are potential risks we need to be mindful of.
Right.
Remember those challenges we talked about earlier? The instability of water.
Right, the leaky fuel tank analogy.
Mm-hmm.
So finding those more stable materials is key.
Exactly. Finding new materials that can mimic water's unique properties while being more stable and efficient is crucial for taking this technology to the next level.
Okay, so finding quantum grape 2.0 is still a big hurdle. What else?
Well, there's also the issue of miniaturization. Right now, these devices are still pretty bulky. To make them practical for everyday use, we need to find ways to shrink them down.
I can't exactly imagine carrying around a bunch of grapes and a laser everywhere I go to use my quantum sensor.
Exactly. But with continued research and development, I have no doubt we can overcome these challenges and unlock the full potential of this technology.
I love your optimism. It's inspiring to think about all the possibilities that lie ahead. But for our listener who's been with us on this journey from grocery store grapes to the cutting edge of quantum physics, what's the one thing they should take away from this conversation?
That scientific discovery can come from the most unexpected places. Who would have thought that ordinary grapes could hold the key to unlocking the potential of quantum technology?
It's a great reminder that we should always be curious and open to new possibilities, no matter how strange or unexpected they may seem. There's still so much more to discover out there.
I completely agree.
Well, we can't talk about all this groundbreaking technology without addressing the elephant in the room.
You mean the potential downsides of such powerful technology?
Exactly. It's all very exciting, but we have to be realistic. We've seen time and again how incredible advancements can also have unintended consequences. So where do we see potential issues cropping up with quantum sensing?
One major concern is privacy. Quantum sensors are incredibly precise, so imagine them being used for surveillance on a scale we've never seen before.
Okay, that sounds a little unsettling. Are we talking about a world where our every move is tracked and analyzed?
It's not entirely science fiction. Think about quantum sensors embedded in everyday objects, streetlights, smartphones, even household appliances constantly collecting data on our location, our conversations, our habits.
So it's not just about big government watching us. It's about the potential for massive data collection from all sorts of sources. That's a whole other level of privacy concerns. What can we do to prevent that kind of future?
Well, it starts with awareness. We need to understand the implications of this technology and demand clear guidelines and regulations around data collection, storage, and use. Who has access to this information? How is it being used? These are crucial questions we need to be asking.
It feels like we're always playing catch-up with technology, but you're right, we need to be proactive, not reactive when it comes to protecting our privacy.
Absolutely. And it's not just about preventing misuse by governments or corporations. We also need to consider the potential for this technology to be used for malicious purposes by individuals.
You mean hackers, criminals, that sort of thing?
Exactly. Imagine quantum sensors being used for espionage, identity theft, or even to disrupt critical infrastructure. The possibilities for harm are significant.
This is starting to feel like a bit of a tightrope walk. On one hand, we have this incredible technology with the potential to revolutionize so many aspects of our lives. On the other hand, we have these very real risks that we can't ignore. How do we find the balance?
It's a challenge, but I believe we can find solutions through collaboration. Scientists, policymakers, ethicists, and the public all need to work together to ensure that quantum sensing is developed and deployed responsibly.
So it's not just about advancing the science, it's about shaping the ethical framework around it.
Precisely. We need to anticipate potential problems and put safeguards in place. We need to have open and honest discussions about the trade-offs between innovation and risk. And we need to be prepared to adapt as the technology evolves.
It sounds like a long and complex road ahead.
It will be, but I'm optimistic. We face similar challenges with other powerful technologies, and we found ways to harness their potential while mitigating the risks. I believe we can do the same with quantum sensing.
I hope you're right.
Yeah.
It would be a shame to let fear and uncertainty stifle the incredible possibilities of this technology.
Agreed. But it's crucial to approach it with both a sense of wonder and a healthy dose of caution. We need to be excited about the future, but also prepared for the challenges that come with it.
Well said. I think that's a great note to end on. As always, it's been a fascinating deep dive, and I'm sure our listeners learned a lot about the amazing potential and the potential pitfalls of quantum sensing.
It's been a pleasure joining you.
And to our listeners, remember, curiosity is key. Keep exploring, keep asking questions, and keep pushing the boundaries of knowledge, but always with a mindful eye on the ethical implications of our discoveries. We'll leave you with that thought. Thanks for tuning in to The Deep Dive.